I have this long-term goal of making a vintage Macintosh API in C. I want to help people get a leg up on programming for these old 68K compact Macs. Specifically for the Mac Plus, which is close to my heart, but this can be used for later models as well. I've been crafting tech demos that deal with graphics, sound, music for literally decades. I think it's time it gets wrapped in a neat bundle that can be used by others. The black and white Macs deserve some quality games. They have been getting a bit of attention lately. But I think we collectively can do better. Programming for Macs is notoriously difficult since there's a lot of Macintosh managers talking to each other. You normally have to read the inside Macintosh books a few times before it clicks. So my solution: launch an API for game programming for black and white Macs. I call it the 1-bit Dream Machine. This targets System 6 primarily and should run great on a humble Mac Plus. If you run it on a faster computer like the SE30, more power to you. You'll probably be able to do more complex frames of graphics in the same time. I've put up a GitHub repo last year during the Marcintosh event of 2025, but it was a soft launch that didn't make many waves. In order to have an impact, I need solid documentation on how to use all of this and easy to integrate library files. Both are lacking somewhat at the moment. However, since I've gotten to a good place with my MIDI playing routines lately, as you can witness from my latest videos, let's start there. You gotta start somewhere. I'm gonna show you how you can easily add MIDI playback to your Think C or Semantic C project. Of course, MIDI playback involves having external hardware with this class of Mac. You'll be using either your modem or printer ports. Some MIDI modules can connect directly to the Mac, like this Roland Sound Canvas. Some require a cheap MIDI interface with one MIDI out port at least and old-style DIN5 MIDI cables. In my GitHub, you'll find this minimalist Semantic C 6.0 project that goes straight to the point with a single page of code. It sets a white full-screen plain window. It writes that you can click the mouse to exit. It loads a standard MIDI file that sits in the same folder as your application. It plays it to the end, then starts over again until you quit. Coding a MIDI file player is pretty daunting. I spent months understanding the nuances and exceptions in the MIDI format. I made a few programs here on this Macintosh platform, like Cozy MIDI and Fire Jam. I also gained a lot of experience on the WildBits new retro computer, a 6502-based wedge computer with a lot of sound chips, including a SAM2695 that can deal with MIDI and is basically a $4 sound canvas in a single chip. My goal is to remove all of that complexity to you, the game programmer, so you can get rich music with none of that effort. You don't need the Apple MIDI driver, you don't need the OMS drivers, none of that. All you need to decide is if you'll use the modem or the printer port. Here are the 4 steps. 1. Include mu midiplay.c at the top of your main project source file. 2. During your initial setup phase of your program, call setup MIDI serial true if you want to use the modem port and false if you need the printer port. 3. Then you need to bring the .mid file into memory, and there are two ways to do it. If it's a standalone file, use prep MIDI file for play and give it a Pascal-style file name string as an argument. For example, if it's canyon.mid, use \p canyon.mid in quotes. If you don't like having a separate file alongside your app, you can also embed the MIDI file inside your application. I'll tell you how to do it later. If you do have that embedded resource file instead of a separate file, then use prep MIDI res for play and use the ID number for that resource. I'm using 128 here. Step 4, you're almost done. Inside of your game loop, all you need to call is the function MIDI loop pass, and that's it. This will take care of the next most urgent MIDI events that need to happen at any given time. It will play your music asynchronously and free up most of the CPU time for your graphics, inputs, and logic that you also need to be doing. Step 5, you're probably going to want to know when the tune ends at some point, so I provided a is MIDI done, which returns true if it's over or false if it isn't. If it is done, you might want to start the tune again and again, so I provided a rewind and play MIDI function with no argument. Once you're all done, the whole main project source can fit inside a single page. I'm kind of proud to have reached this level of simplicity that hides so much pain and misery, which lasted months on and off for me. So what kind of fun thing can you do with MIDI playback? Remember Dark Castle and its great intro screen. You can hear a short sound clip of Bach's Toccata and Fugue in D minor. It sounds awesome and it fits the mood of the game. But it's so short. It would have been impossible to fit the entire piece of music in the original low-density diskette in 1986. Do you see where I'm going with this? We can play a what-if game here. What if MIDI playback was way more popular back in 1986 and games were ambitious and included MIDI playback in their games? Thanks to my library file, I can sort of realize the dream of using the full piece of music here, playing over this still capture of the intro splash screen. So where can you find these source files? Just go to my repo. It's under construction, but you'll see the exact same source files as the demo projects I just showed. Follow the instructions in the README and you'll be able to get going with Think C or Semantic C++. I'm sure it can be adapted to CodeWarrior or others. You'll also find that I'm adding extra library files that are useful on other topics, such as this hide menu bar and show menu bar functions that are quite useful for game programming. In time, I'll have source files for graphics, sprites, the sound driver, and all aspects of game programming. A big push needs to happen with documentation though. So, a word on how to embed the MIDI file. I found that using Resourcerer, a kind of competitor to ResEdit, was the easiest way to do this. Open the MIDI file's data fork, open your Think C project resource file, and create a SMF resource type. Don't forget to add a space after the F. Copy the MIDI file data content to the resource and save it. That's it. I found that using ResEdit wouldn't allow me to copy that big chunk of data somehow. That'll be it for now, so I'll leave you with the full Toccata and Fugue by Johann Sebastian Bach in D minor. Enjoy.